Okay. Good morning, everybody. Thanks for being here. We are a little bit short today. I know a number of students are out from class today, either with sports or illness. So thanks to everyone for being here. We're going to go ahead and get started today and continue talking about bones and maybe even get into the axial skeleton. But first, I want to make an announcement and then take some questions and make sure we're clear about how the lab works from last week and everything like that. I know I brushed up on it on the end of last class, but I think there might be a really good question to answer here. So first, though, and just a quick reminder is that Tuesday afternoon is the first in our biology seminar series this semester. We have Dr. Andrew Mason from the Ohio State University coming to talk to us about his work with vipers. Should be really great. Please pass the word around. Note that there is a pizza dinner with Dr. Mason afterwards if you're interested. Actually, I'm organizing it and hosting him, so just email me. So today's agenda, we're going to start off with a quick review of the types of bone cells. We'll get into bone classification. I have a drawing activity for you as usual. We'll talk about the axial skeleton, and then we'll wrap things up with a ticket out. And it is Friday, so you get your Friday Venn diagram. And today's is very breakfast oriented. You'll see what I mean. But before we get into this, for class today, you had a survey to do, a reflection. I wanted to get some information and thoughts from you on how quiz number 1 went, and also some readings and some videos, of course, kind of the standard, what you'll find is kind of standard in the class program. It's usually some textbook readings. I really like this Crash Course A&P series. It's really almost surprising how nicely those videos align with our course content sometimes. And he's kind of fun and engaging. So they're really well done videos. They're pretty short. So before we get into this, though, I want to see what questions you have about the lab. I know Gia asked a great question about how that lab worksheet will be graded. So just to back up for 1 second, remember that each lab has 20 points associated with it. And each lab, the way those points are allocated will be slightly different. In this week's lab, you have 2 points associated for your Getting Started quiz in Visible Body. And I set that up so you could take that quiz as many times as you like till you get a perfect score. The idea being that I want everyone to get full points on that because I want to make sure you know how to use the software. There's 8 points allocated for the anatomy worksheet that's in the Google Forms. That you're getting graded for how do I want to say this? For completeness and correctness. However, if you get, there's a lot of questions on there. So if you get 1 or 2 wrong, you can still get full credit, right? And so what I'll do is I'll grade those. And if you get half of them wrong, then you'll get a lower score than obviously 8 out of 8. But and I should have explained this earlier. I apologize for not, but I'm grading it on a way. I want to make sure you understand the concepts. And to me, if you get almost all the questions right, that shows me you understand it. You'll get an 8. So do your best on it. Make sure you understand, do a thorough job, but also it's not graded the same way as like a quiz or a test would be. Does that clarify?
Yes.
Yeah, I'm really glad you asked that. I appreciate that question. And then the other 10 points from lab, just as a reminder, are a quiz that you'll have in lab on Tuesday. All lab quizzes are closed book, so be prepared for that. And this one is specifically on anatomical terms, as well as the cat dissection. What other questions you have? Okay, well, let's get into it then. Just as a way of reminder, we covered this on Wednesday, but I want to just back up for 1 second just to offer a quick refresher. Remember, there's 4 types of cells present in bone, and 3 of these types are responsible for producing and maintaining the actual bone structure. These include osteogenic cells. These are like the baby osteocytes. Excuse me, I said that wrong. They're the baby osteoblasts. So the osteogenic cells develop into these osteoblasts, which produce and secrete this solid bone matrix. That's these mineral salts. Just as a mnemonic device, remember osteoblast, B for build, because they're building up the bone. And then we have the osteocytes, which are these cells that basically serve a maintenance role and make sure that nutrients are being exchanged, waste is being removed, that kind of thing. The 4th type of cell is a little bit different. It is involved with resorption, and it is called an osteoclast. and is actually derived from a line of white blood cells. So it's a kind of immune cell that breaks down bone, and then that provides space for the osteoblasts to build up more bone. This is all review, so I'm going over it kind of quickly just to refresh your memory. We wrapped up class on Wednesday. You drew a diagram of each of these 4 cell types and just explained briefly what they were, and you left class with a little study guide. Any questions on that material before we dive into some new stuff? Hey, Ren. All right, so let's talk about how we classify bones on a gross anatomical scale. We have 4 kinds of bones that are classified simply by their shape. And first, we have what's called long bones. These are bones that have a long shaft, and they're longer than they are wide. So this is something like the humerus and the ulna and the radius in your arms, your femur, tibia, fibula, all of those bones, pretty obviously. Also note that your fingers, the bones in your phalanges, are considered long bones as well. Notice that long simply means they're longer than they are wide. It's about the shape. It's not about the size. So you can have, kind of oxymoronically, you can have short long bones. Like some of the bones in your phalanges, they're not very big in an absolute sense, but they still have that distinctive shape, so they're considered long bones. The second type of bone is called a short bone. And these are bones that are kind of cube-shaped. We don't have that many in your body. One good example is your talus, which is a bone in the heel of your foot. We also have flat bones that are thin and as you might guess, I'm defining these by their name. They're named after their shape, so it's kind of intuitive. But these guys are flat, as you probably guessed, and they're often kind of have a curvature to them. So the sternum in the center of your chest is a good example. Your skull is an example of a flat bone as well. Of course, it's flat, but it's also curved in the sense that it's shaped around, well, provides the shape for your head. And then finally, we have what's called irregular bones. This is just kind of a catch-all for wackamodoodle shaped bones, something like your vertebrae. Like you can see, there's no easy way to describe or classify the shape. It's got all these different pieces coming off of it. And we just kind of lump these together in the category of irregular. We're going to spend a little bit of time talking about the anatomy of long bones. I'm going to focus on that more so than the others. And we'll have a chance to explore this more in lab, not this coming week, but the week after. You'll spend some time and you'll get hands-on examples of all of these. So for now in lecture, I just want to introduce the idea. In lab, you'll explore this in a lot more detail. And this is a topic that I think is much more useful to learn hands-on, where you can get all of these bones in front of you, you can pick them up and look at them and that kind of. So with that in mind, let's talk about long bones in a little more detail. And I want to introduce you to some important terms here. That includes, let's kind of just walk through these. The first is the periosteum. This is a type of connective tissue that basically covers the outside of the bone. And it contains both osteoblasts and osteoclasts. So remember the 2 cells that are responsible for building up and breaking down the bone tissue itself. So it's this thin outer covering around the bone. If you've eaten chicken wings recently, you've probably seen this when you're kind of pulling the meat off the bone, and then there's like that thin layer that's between there. That's the periosteum. We also have 2 types of bone tissue. We have what's called compact bone and spongy bone. Compact bone is the dense outer layer. You can see in this cutaway diagram here, it's this part of the bone here, and this side, it kind of goes around the bone on the end there as well. And I'll talk a little bit more about the structure of this bone, but what I want you to know for now is that it's the outer layer of bone, and it's very dense. Then the bulk of the volume of the bone is made up by what's called spongy bone. And this is bone that kind of looks spongy. So it's not solid like this compact bone. There's rather this kind of network of structures and pockets of tissue. And these network of structures are called trabeculae, which means little beams. So you can think of it as all of these little beams kind of forming around these pockets. And so this allows your bone to be strong, but also reduces the weight of the bone because this material isn't as dense as the compact bone. We also have the space in the middle generally the middle of these long bones, called the medullary cavity. And this is filled with red and yellow marrow. I'll talk about that in a little more detail. So we have this inner space. So again, working from the outside in, from the superficial to deep, we have the periosteum, which is this outer covering. We have the compact bone, which is the dense bone layer. We have the spongy bone, which is the less dense bone layer built from these trabeculae. And then we have the medullary cavity in the center, which contains red and yellow bone marrow. So let's look at some names of the different parts of the bone as well. The first I want to talk about is the diaphysis, which is basically the shaft, the middle part of the bone. Then we have a distal epiphysis, which is the far end, and the proximal epiphysis. So these two, the plural is epiphyses. These are just the kind of more bulbous end of the long bone, and it can be on either end. You see blood vessels going into the bone. Remember, all of these cells need to be fed with oxygen and nutrients, and waste need to be removed. So your bone tissue is in fact highly vascularized. And we have these little holes called foramen, plural is foramina, that allow these blood vessels to go through the periosteum and the compact bone and get to this medullary cavity in the center. The medullary cavity I just mentioned. And let me back up for 1 second. I want to see something here. Yep. And then we have the periosteum, which is on the outside, I mentioned. We also have another type of connective tissue lining the inside of the bone that lines this medullary cavity. That is called endosteum. So you'll see these two prefixes often in class, peri and endo. Actually, this comes up again and again and again. So just to make sure we've got a good note of that, peri refers to something on the outside, and endo refers to something on the inside. And these two prefixes come up again and again in anatomy and physiology. You've probably seen them in other classes, actually. So the periosteum is on the outside, endosteum on the inside. And then finally, we have these special collagen fiber, these bundles of collagen fibers that hold the periosteum to the underlying bone. And those are called, well, they're called Sharpie's fibers. I'm not going to ask you that. I just want you to know that there's these collagen fibers that adhere that periosteum to the bone tissue. You can see a nice diagram there. One thing that will definitely come up in lab, absolutely need to know what a diaphysis is and where the epiphyses are in relation to each other. I also want to point out in this diagram, we'll talk about this more in lab, but it's worth mentioning now. This is called the epiphyseal line. You can see how there's this kind of line of denser bone in between these two kind of compartments of spongy bone. That is also known as the growth plate. You've probably heard that term in the vernacular. This is where new bone tissue is formed when your bones are growing, basically up until your late teens, early 20s, maybe even younger, mid-teens, depending. It varies from person to person. But this is where new bone is formed as these bones grow longer during development. Once you reach maturity and those long bones stop growing, then this epiphyseal line isn't the site of growth because your bones aren't growing any longer. They're as long as they're going to get. So let's get Julia and then Gia.
Like can see some bone like here in your hand, and they can tell like how tall you would be. How does it?
I don't, that's a great question. I've heard that there's like, they can kind of predict your height based on your size at a certain age or something. And I don't know if they use, your size and say, oh, you're, 72 inches long when you were 18 months old. And so that means you're going to be 5'4", whatever that is. I don't know exactly how that works. But the rate of growth of these long bones is really what determines your height, because most of your height is determined especially by those long bones in your legs. But if there's a precise way to do that, I'm not sure.
X-ray of this part.
Okay.
They would just run out the bones and then they're like, oh, it would be like.
Did they do this for you? Was it accurate? Yeah. Huh? No, I'd have to look. Yeah, see if you can find more information about that. I don't know exactly how they did it. I'd be curious. Chia, go ahead. Mhm. Yeah, so essentially what happens, so this epiphyseal line you see here is actually the remnant of a growth plate. So this is an example, I should be more clear. This is an example of a mature bone that's not growing anymore. And once you reach maturity, let me back up. When you're younger, this growth plate is actually lined with cartilage that develops into bone tissue. So you can see I have some x-rays of this. I don't have them handy, but we'll see them in lab. I should love to show you, well, I'll get to it. But you can see in an x-ray of like a kid that there is two bones essentially here that are connected by this line of cartilage. And that line of cartilage is where the new bone tissue is developing to grow out. Once you're an adult, that cartilage is gone and it's replaced by solid bone. And you can see that very clearly in an x-ray. And at that point, it's not developing anymore. Yep, so you can see, we see examples of that. I actually have some cow bones in the lab where you can see that growth plate really clearly because they're from baby calves. Yeah, yeah, not mature cows, and then we can compare that to the adult bones. Great question. Go ahead, Taryn.
So when I was the freshman, my growth plate in my wrist, and I don't know if they just like didn't leave the cast on long enough or something, but I still had pain in it like all the time. Is that because it was a growth plate and it wasn't done?
Great question. I don't know if it's specifically because it was a growth plate or just it didn't heal properly, or it could be the case that your bone is actually healed, but other tissues around it still haven't healed properly. So it could be any of those things. Actually, when I was 4, I broke the growth plate in my elbow like super bad, and they had to do surgery. I still have a giant scar. They had to like put pins in and fix it because if they didn't do it properly, my arm wouldn't have grown anymore from when I was 4. Fortunately, they did it perfectly, and I had zero problems with it. But I was pretending to be a superhero and jumped off the top of a bunk bed. Yeah, it's one of my. Yeah.
I started laughing at first, and then I
And
went back, and she was like,
we were so yeah, you're like, oh, that hurts. Yeah, at first, yeah, it was not fun. Okay. Right. Because it still had just a little bit of growth to do. Yikes, that must have been painful. The femur is, yeah, it's a big old bone. Yeah. Wow. Yeah. And that's exactly it, because that growth plate, until it fuses completely, you're still going to get additional growth. So even if you're close to being done growing, you'll still be shorter on that. Cool. Good growth plate breaking stories. I like this. Yeah. Did you really? Were you jumping off a bed pretending to be a superhero? Oh no, that's a much worse story. We're gonna have to have the broken arm club or something in here. It is, having said all that, it is amazing. Two things I think that are really incredible about that is, one is the medical technology that they can go and kind of fix that so the 4-year-old arm can grow normally for the rest of their life. And two, that your bone has this regenerative power that it really can heal itself quite remarkably. And that is, to bring it back to our content here in class, that is largely, it's largely due to the fact that this is constantly regenerating tissue. So you have the osteoclast breaking down, osteoblasts building up. It's highly vascularized, so it's very dynamic tissue, and that allows it to heal. And this is in contrast to cartilage. So you see some blue cartilage here. What kind of cartilage is this? Hyaline. Yeah. And hyaline cartilage lines the ends of your joints. And you can see that here. You can see a little bit at the top. This tissue is not vascularized. And so when that gets damaged or deteriorates with age, it's very, very slow to recover, if it can recover at all. And that's what something like osteoporosis is, when you don't have any cartilage, or that cartilage, I shouldn't say you don't have any, when that cartilage gets degraded or frayed in those joints. And there's really no good way to heal that or replace that. Although there's some new advances that are helping with that, but in general, like once it's gone, it's kind of gone. It makes it hard and painful to move. And this is why like joints often just get replaced wholesale, like your knees or your hips. And so I can, well, I'll actually show you an x-ray, but I had severe osteoarthritis in my hip joints where there's basically no cartilage. And so a year and a half ago, like my hips were really hurting when I'd exercise, and I went to the doctor and got x-rayed, and they're like, oh, you have the hips of a 70-year-old. You need to get it replaced. And I was like, awesome. So I had both, actually both of them replaced because there was just no cartilage in the joint at all. Well, very little cartilage. It wasn't enough to do the job. So.
They don't know why yours like wore down so quickly.
No, it's real. Yeah. So I was really young to need double full hip replacement. But no, what's weird is my brother, I have a younger brother, and he had one of his replaced a couple years ago too. So I don't know, it could be genetic. We just blame our mom because that's what moms are for, right? So just, yeah. If she didn't yell at us so much when we were kids, we would have better hips. She likes that. And so any medical issues, you have broken wrists, just blame your mom. Yeah. Good. All right, let's continue talking about the anatomy of these bones in a little more detail here. So this is a cutaway of a long bone. Again, you can see these arteries. We can see, I like this diagram because you can see these collagen fibers a little better. These are like what's allowing this periosteum to adhere so closely to this underlying compact bone. Here we see the yellow bone marrow. I want to back up. I didn't make this clear on my slides, and I should have. Is that there's two kinds of bone marrow. I'm going to put this on the board. I think I have this in an upcoming slide, but I want to make sure we've got this. Two kinds of marrow. We have yellow, which is fat stores. Remember, I said that one of the roles of your bone tissue is to serve as an energy repository, basically, and that's what fat is. Fat is an energy repository. It's your body taking potential energy and putting it in a really dense chemical, a molecule that can contain a lot of energy, like your lipids and your triglycerides, and that's what fat is. We also have red marrow, which produces blood cells. So two kinds of marrow in the middle of those long bones. You can also see here in more detail, you have the endosteum, which is that connective tissue that lines the inside of that cavity. And you can see this diagram that blows up this spongy bone. You can see these trabeculae in more detail. You can see how blood vessels can kind of weave their way through there. Again, this is living dynamic tissue, so it's got a lot of blood vessels going in there. I've said that like 2 million times. That's the general structure of long bones. Yeah, let's talk a little bit about flat bones, okay? So flat bones are, flat bone structure are actually pretty similar to irregular bones and short bones, but I'm just going to talk about flat bones, and I'm going to use the skull as an example. They have a similar structure. Okay, I was just thinking about how I wanted to phrase this. They have a similar structure to the long bones in that they have compact bone on the outside. Notice that when I say outside, I'm referring to both the side that is facing the outside of the body and the side that's facing the inside of the body. So it's on both sides. The superficial and the deepest layer of the bone are this compact bone. You can see that dense layer here and here, and it has spongy bone in between. In flat bone, I don't know why, but in flat bone, we call this spongy bone diploe. So it's the same, basically the same structure as your long bones. It's these trabeculae, this network of these kind of beams. And in flat bone, it has a special name. Your flat bone also, interestingly, contains some red bone marrow within this diploe, but it doesn't have this cavity. That marrow isn't kind of centralized like it is in the long bone in the middle. It's kind of dispersed throughout that spongy bone or diploe. That's all I really want to say about flat bones. Just know that there's takeaway message here. No cavity in the middle, still has layers of compact bone and spongy bone. And that spongy bone has a special fancy name called diploe. Your bones are, we're going to see this more in lab, but what is really cool about your bones is the way they grow and develop is really remarkable for doing the job they need to do, and specifically withstanding the stress. So you think about something here as your proximal end of your femur, so this is the head of your femur. This is a ball and socket joint into your hip bone. So this is going to be your coxal bone, hip bone right here. And the way that the bone develops, both internally and externally, allows the bone to withstand a great amount of pressure on it. And they develop in a way that they can withstand the pressure based on how that pressure comes. So in this case, we have the load of your body is pushing down on the head of this femur, and your bone structure, without getting too much into the physics of it, the internal bone structure kind of creates this arch that allows that force to be distributed in a way that the bone can handle it extremely well. And what happens in a case here is when you think about stress being pushed on this, it's going to compress one side of your bone while creating tension, kind of pulling forces on the other side of the bone. So in the middle of that, you have a point where there's no stress in the center of the bone. And so this allows your bones to be both strong and lightweight, which is pretty cool. And what's important to note is that the stresses that you put on your bones determine how it grows. So this is why one of the many, many reasons that physical activity is so important, especially when you're young, because the actual activity you do, moving around, putting weight on these bones, your bone tissue responds to that and grows in a way that allows the bone to develop in response to those pressures so that it can best serve you. So if you have a sedentary lifestyle from the time you're a little baby and don't move around as much, your bones won't develop in the same way as a kid who's running and jumping and all of that kind of thing. So that's important. And that's also true throughout life. That's maintaining good bone mass, especially when you get into your upper decades, is super important to maintain that bone, because the bone tissue responds to the stresses that it's put on it. We'll talk a little bit about more about bones and development later on. I have one slide here that I'm going to skip over because we actually get to this in lab, and I think it's much more useful to talk about in lab. Basically, this is just a slide with vocabulary about the different features of bones, but I don't want to cover it in lecture. I will just save this one for lab. So what questions do you have for me right now? All right, we're going to do a quick drawing activity. This is designed to take a couple minutes. So bear with me with this activity for a moment. I want to remind you that one of my recommendations for this course is to study as actively as you can. And by that, I mean a good example is don't just look at a diagram of a bone with the parts labeled and try to memorize it. Recreate that diagram by hand. As much as you can, try to generate the knowledge that you're trying to remember rather than just kind of reading it and trying to memorize it. So a lot of activities we do in class are designed to do that. Part of the purpose is to allow you to do in class, but part of it is I'm hoping that you can get some study skills that might be helpful later. So what I'm going to ask you to do now is, as best you can from memory, so without consulting your notes, I don't want you to look at anything, take 2 minutes and draw and label a long bone, and draw and label as many parts of it as you can from memory for 2 minutes. After 2 minutes, we'll go back and we'll consult your notes and you'll add to it. But I really want, this is a good chance for you to see what you know and to try to pull as much of that from memory as you can. And we just learned this, so I'm not expecting you to know. There's no expectation here. This is a study tool, not a test. Got about 30 seconds left. Just try to jog your memory, see what you can do. Don't worry about artistry. Oops. All right, now go ahead. We're going to take another 2 minutes and consult your diagrams. And what I want, consult your notes, excuse me, and update your diagram. And what might be useful for you now is to note what things you already know and have memorized and you're good, and what things you're adding now so that you can know that that's what you need to study for next time. It's kind of a self-assessment, helps you know what you need to know. All right, you got 4 minutes of intense studying down, and you have a diagram that looks probably something like this. This is obviously from a book. Important takeaways here is you have epiphysis on the proximal and distal end. You've got the diaphysis in the middle. Make sure you're noting where we have the oh, interesting. I picked a diagram that doesn't have compact bone on it. You should have compact bone for sure. Spongy bone in the middle. You have your periosteum on the outside, endosteum on the inside, and your marrow in that medullary cavity in the middle. Of course, there's other things you can add as well, but that's kind of the larger takeaway structures there. Julia.
The flat bone, it still have like the periosteum or not?
Which bones? The flat bones?
Yeah.
Ah, great question. Thanks for asking that. Yes, the flat bones still have the periosteum as well. So let's talk about osteoporosis a little bit. This is probably the most famous of the bone diseases. The basic gist of this is that what happens is the bone reabsorption by osteoclasts happens at a faster rate than new bone matrix is built by the osteoblasts. And you get something that looks like this. Basically, those trabeculi become longer and thinner, and your bone loses its integrity. It often happens later in life, more often than and even more often it occurs in women after menopause because of the change in body chemistry and hormonal balance, your bones don't deposit that, don't process the calcium as well to create that bone structure. And so that's the gist of osteoporosis. Unfortunately, it's irreversible. So there's ways to kind of slow it or prevent it from happening in the first place. But once your bone structure gets like that, there's no going back and building up more bone structure, at least that we've been able to figure out so far, which is why it's so important to develop habits earlier in life before you get to that point, so that the risk of severe osteoporosis is reduced when you're older, because it's not something that you can cure once it happens. That's all I want to say about just one slide. Your textbook, I gave you some readings. I don't remember if they're for the readings for today or for Monday, but there's a short section in your book on osteoporosis. Basically, your bones become brittle and are subject to breaking much easier. And I think I mentioned in class about, you often hear about older folks getting the broken hip, that it's actually the break that produces the fall, not falling and then that producing the breaking. So we've learned about the structure of bone tissue. We've gotten into the cellular detail of it. Let's talk about the names of the bones and where they are in your body that make up your skeleton. And I really should restructure this class and have this section right around the week of Halloween, but we'll do it now. So your skeleton it consists of a number of different tissue types, including your bones, your cartilage, joints, which we'll talk about in more detail in lab as well, and ligaments. Ligaments are this dense connective tissue that is binding bones to bones, and it forms important parts, especially around your joints. Important parts of the skeleton, especially around joints. Your skeleton is composed of more or less 206 named bones. So not everyone has the exact same number of bones. Sometimes we get little bonus bones. I'll talk about those in class. Generally, they're pretty inconsequential. And probably a lot of you have some extra bones and don't even know it because they're tiny and you don't really notice them. But I want to note that we have 206 named bones, but that can vary by a few. But generally, we divide the skeleton into two major areas. The first is the axial skeleton, which axial referring to an axis or what's down the center. This is your skull, your vertebral column, and your thoracic cage. And we're going to focus in class here to start on what I'm calling the postcranial axial skeleton. So post referring to after, cranial referring to skull. So basically the axial skeleton that comes after your skull. The reason is we're going to go back and do a whole unit on the skull in a lot more detail. So I'm going to start basically talking about the skeleton from the neck down here. And we'll talk first about the vertebral column in the thoracic cage, which composes this postcranial axial skeleton. And then we'll talk about the appendicular skeleton. This is all of the other bones that form your limbs, your arms and your legs. We look at this in another diagram. Here we have the axial skeleton in this kind of weird blue-green color. The skull, we're going to ignore for the moment. So the postcranial axial skeleton, you can see all in highlighted here. We're going to focus on two parts of the axial skeleton. We have the thoracic cage. It's called the cage because it forms a cage around the organs of the thoracic cavity. And this is basically your ribs and your sternum. And then we have the vertebral column. And that's this series of bones that go from your from just below your skull all the way down to your caudal area, and basically your bum. So we have the long vertebral column, we have this thoracic cage. And I want to talk in a little detail, actually, I think we can talk about this. I want to just talk about the vertebral column. It's also called the spinal column and also called the spine. Those are all the same thing. In an adult, it's formed by 26 bones. And I say when you're an adult, because when you're young, some of these bones are separate bones, but they become fused in the adult. And what this vertebral column does is it transmits the weight of your trunk. So all of the stuff that's up top, it basically gives that structure and then transmits all of that weight down to your limbs. So the lowest bones here articulate with your hip bones and transmits that weight from down your body into your legs. It also, very importantly, surrounds and protects your spinal cord. Your spinal cord is the nerve column that runs down the center of these bones. We'll talk about that when we get to the nervous system. But just make sure you're keeping the term spinal column and spinal cord separate. Spinal column refers to these structures, primarily bones and associated tissue, ligaments and cartilage. The spinal cord is the nerve of your central nervous system. Additionally, the spinal column, I just said careful with those terms and then I mixed them up. Your spinal column, the bones, your vertebral bones serve as attachment points for muscles that allow you to move your head and your neck and your torso as well. I should have actually put torso on there. You notice that we have these 26 bones broken down into these regions here. And let's walk through what those regions are. So you have 5 major regions of the spine. I apologize, you can see the diagram here. I'm going to add my own text. There's text here. This is from your textbook. So you have this diagram. So don't worry about the small text right now. I'm going to provide some larger text. But you have 5 major regions. You have 7 cervical vertebrae. So those are the vertebrae up top in blue that are your neck vertebrae. You have 12 thoracic vertebrae. Those are in green, associated with your trunk. Then you have 5 lumbar vertebrae, which you see in gray, which, as you might guess, are the vertebrae of your lower back. And then you have one bone that's called your sacrum that is composed of 5. When you're young, you have 5 separate vertebrae, and during development, they fuse together and form this single bone, the sacrum. And then we have the sacrum is inferior to the lumbar vertebrae, so it's on the bottom. And then the last bit we have here is this little bone called the coccyx, which is composed of somewhere between 3 and 5 fused vertebrae. This is commonly called your tailbone. That's the very, very most caudal or inferior end of the spinal column. So I often see that there is a mnemonic device that's often used to remember how many vertebrae are in each section here, and that is this. There's 7, 12, 5. And the mnemonic device, I think your textbook has this, is it like the times of day that you eat meals? So you eat breakfast at 7, you eat lunch at noon, you eat dinner at 5. For me, eating dinner at 5 seems really weirdly early, but whatever. I guess it's a way to remember it. So you have 7 cervical vertebrae, 12 thoracic vertebrae, and 5 lumbar vertebrae. My parents eat dinner at 5 sometimes, and I think it's super weird. It's like 4:45, and they're like, "Are you ready for dinner?" I'm like, "What? No." 7, 12, 5. Go ahead, you. Yep. Oh, the number that are fused together for those? I'm not going to ask you that, no. I want you to know those bones and where they are, and we'll get into more detail here in lab. And you'll definitely need to know the 24 bones that are in the cervical, thoracic, and lumbar. Fortunately, they're all labeled. It's just C1, C2 through C7, T1 through T12, and then L1 through L5. So once you know those 3 regions, you know all the bones. Cool. All right, let's wrap things up here. I'm going to get into all of this fun stuff about all this. Look at all this stuff. All right, a couple announcements before we wrap up. Quiz number 2 is coming soon. It's going to be a week from today. It's going to cover the integumentary system through whatever we cover on Wednesday of next week. Like your quizzes, all your quizzes, it's worth 30 course points. And I'm not going to announce the format yet. The reason is because I gave you that survey that you finished for class today. I want to read those over and see what worked and what didn't for you with the first quiz, and then using that information to kind of figure out what makes sense for the second quiz. However, I do want it to be on your radar. There's details about it in your class program. Don't forget you have a quiz in lab on your anatomical terms in your class next week. And with that in mind, your tutoring session with Danny on Monday evening will be in the lab so you can review all of that stuff as needed. As promised, here is your ticket out as well as your Friday Venn diagram. I'll be happy to answer any questions. Otherwise, once you complete the ticket out, we're good to go. Have a great weekend, everybody.